Yeah, the homework's in the back. I saw somebody really clever last lesson. As I was teaching along, they were flipping the page over and starting the homework while I was teaching. That's clever stuff. You're like, oh wait, he just taught this. I can do that one. Boom, boom, boom. While you're waiting for people to copy who claim they can't see past me because I'm so fat or whatever your little stories are. Factoring a difference of squares, it's called. Expand and simplify. Look, again, folks, these lessons are designed to force you to do other skills. See, we did this. We did expanding. So here we are, we're going to review it to make sure we got it. Now, how many people would think that they're like a box or a window person if they were going to do this? How many people are like a FOIL person if they're going to do this? And how many people don't really know which method they like? All right. Here they come again. Same stuff. Box people. When you have expand, here's what you do. You could have your assignment out. Isn't there a box method on the assignment? Yep. You could have that sitting up higher on your desk going, oh, I'm ready to go. Expand. Number 3 on the assignment. You could have that sitting there going, oh, it's 3 in 1. It's reviewing. It's doing something in today's lesson and working on your assignment at the same time. Box method. Here it is again. You draw. Maybe it should be called boxes method. You draw multiple boxes like this, and if you're doing x plus 6 and x minus 6, you put x and 6 along one side and x minus 6 along the other side. It actually doesn't matter if you put the x plus 6 along the top or on the side. That won't matter. You'll get the same thing either way. Okay? Then you just multiply each box. See, this helps you get organized. FOIL, you got to really know what you're doing. Here, you just like, oh, I just do what's in the boxes. Now, you need to know a little bit of algebra. X times x. See, most everyone's saying that out loud, and that means things are going well. When you first see this in grade 9, people have trouble with x squared and understanding what that means. It just means x times x. The other ones are easy. 6 times x. Yeah. Negative 6 times x. And then negative 6 times 6. Now, when I say that's easy, I don't mean like you should be able to do it in your head. That's not what I mean. It's just that most people can type that into a calculator. The other ones I can't type into a calculator. I got to know. Calculator doesn't have x's on it, but negative 6 times 6 is right in your calculator. What is it? There's one more step to expanding, which is writing all these things down. And I'll write it in 2 steps. I think I just have enough room. I got carried away with my boxes. X squared plus 6x minus 6x minus 36. Mr. Todd, you're saying you just write down what's in the boxes? Yeah, that's what's nice about boxes. It almost seems too easy while you're doing it, when you're doing the boxes. I can see how people don't like it. Those FOIL people out there. They don't want to have to draw all this stuff out. It seems to take a long time. But look at this one. And this is the point of today's lesson. Plus 6 minus 6. If I have plus 6 and I subtract 6, I end up back at 0. Yeah? That always happens when those two numbers are opposite each other. So this one comes out to x squared minus 36. And some people think that's really weird looking because it doesn't have an x term anymore. And it only happens when it's a plus 6 and a minus 6. Let me repeat that because we're going to need that information in just a minute. Yeah. It only happens that you end up with 2 terms here when it's plus 6 and minus 6. Or plus 2 and minus 2. Plus 5 minus 5. They have to be opposites. FOIL people. You're up here going, I don't need to draw all that. I can get the same information by just drawing some arrows, going, okay, x times x, those are the first ones. That's why FOIL. Then the outside ones. Then the inside ones. And then the last ones. And FOIL people, if you're a box person and you're starting to get good at box, you might be at the point where you're like, oh, I don't need the box anymore. I now get what FOIL was trying to do. It's doing box method, but it's doing it. Is it faster? It might be faster. It certainly takes up less space. But I'm not doing a sales pitch for it. I'll be quite happy to see the one. When I see box, when I see people do box on quizzes and stuff like that, I'm like, they're going to get this right. I'm confident. Anybody who draws the boxes goes, this is going to work out. FOIL people can get themselves messed up a little bit. Make sure you're good at it before you switch to FOIL. Okay? All right. Let's try another one. 2x minus 7, 2x plus 7. This time I'm going to make the box just a little bit smaller, only to fit it in. I don't know how much room you have when you have this on a printout. Is there lots of room for a box there, or is it sort of cramped? Oh, you got a little space because it's over there. Okay, so. And again, it doesn't matter.
Foil's just easier for this one.
You like foil better for this one? I'm going to do both. And again, I'm really trying hard not to do a sales pitch where you think that I care which one you do, because I don't.
Also, there's going to be no questions on a test and stuff.
And no, and there's no question that's going to say, oh, you have to do this one by box method. If I say, please expand this using box method, it's actually a hint that I'm trying to give. I'm trying to help. You could use box method. If you then foil, I'll be like, yeah, that's fine. You can totally foil if you want to. But when I say box method, I'm actually trying to be a nice guy and say, why don't you try box method? You know, so you know what I'm asking in the question. Right? So then you multiply these out. There's one slightly harder though, 2x times 2x? 4x squared, because you got to multiply the 2's as well. The other ones are not too bad, although you may need your calculator. That's fine. 2 times negative 7. Maybe that's not something that processes for you. So you punch in your calculator. You get negative 14x, and this one's positive 14x. And then 7 times negative 7. Negative 49. I love that you're trying, though. I love that you were close. This is how you get better at them, is trying and seeing how it goes. But that's not all. You have to collect them up. I'll do it in 2 steps. Some of you might be actually doing them in 1 step. And that's okay, too. I get 4x squared minus 49. FOIL people. Exact same information, exact same stuff, but you'll just do it with little arrows. You'll go, okay, let me write up here, FOIL. You multiply the first ones together, and you get 4x squared. You multiply the outside ones together, and you get positive 14x. That's the O in FOIL. Now the inside ones, negative 14x. Now the last ones. And you get the exact same thing. Good. That's not today's lesson, by the way. That was, what day of the week is this? Tuesday? I feel like that was like about last Wednesday. Then we practiced on Thursday. We tried to do reverse on Friday. Like, we've been using this thing a lot. So if it's just purely by repetition you're starting to get it, that's good. That's why these lessons are designed the way they are. Today's lesson is, isn't this weird how these two played out? Obviously, I chose these questions carefully. Can you see what I'm up to? How did I choose the 2 questions so that something interesting happened here? Yeah. One's positive, one's negative, and the same things in both brackets. Yeah? So what similarities do the answers share? So what happened then? Well, there was only 2 terms in the answers. It wasn't a trinomial like we saw in the other ones. That is huge. How are we going to know when this happens? When we only see 2 terms in the answer. Next, they both had subtract. And again, I don't know what your English teacher would think about these sentences I'm doing here. I'm trying to keep it as brief as I can. Both had subtract. Now the tough part. They had both addition in here. Oh, I'm talking about the answers here. So let me highlight what I mean by that. You're right, I didn't make a big enough deal out of the fact that I'm just looking at the answers now. They both ended up with subtract in the answer after it was all done. I know the initial ones had add and subtract, and that's definitely something I'm going to need as I go to do these questions. There's one other thing. Take a look at these numbers.
They're both squared.
They're everything. I didn't switch back out of my highlighter. Sorry, just a second here. Back to the pen. Everything. Everything is squared. Oh, maybe somebody's bothered by that. You're like, not everything's squared. I'm like, yeah, everything is something squared. Look at the x's were squared. 36 is something squared. It's 6 squared. 49 is something squared. It's 7 squared. These have a fancy name. We don't need to use this name, but they have a fancy name. These are called perfect squares. They square nicely from regular numbers. Okay? So when this happens, we're looking for squares. Okay, I'm looking at my sheet. It looks like I'm 1/3 way through the lesson. Oh, you're bored out of your mind on a Tuesday, don't worry. I'm about to wrap it up, and you get another chance to do some homework.
To not get fired.
Yeah, to not get fired. But Ms. Todd, we don't get paid.
You can't get fired.
Huh. I'd be willing to do a homework challenge
Why do you want to be fired?
for some treats.
You're not paying me.
Everybody does their homework. Mr. Todd buys treats.
I don't know.
I gotta leave in 5 minutes.
All right. I better hurry up to the main point of the lesson then so you can do your homework and not mess up the treats for everyone else, eh? Or you can watch the video later. I'll email your mom so you don't forget to watch the video. Can't tell if that's good. I can't tell if you're happy about that. If you're like,
What point of the video are we at right now? Do you know like what time?
no, no. But it fast forwards along. It's good. You just fast forward along until you're like, oh, that's where I got to pick it up. Okay, a polynomial of this type is called a difference in squares. Recall that difference means subtraction. So here's the steps. When you're trying to do this, I'm going to go in reverse now, factoring in different squares. Steps involved in factoring in difference of squares. Check if there's two terms. To be able to do this, it's got to be two terms. That's the only time difference of squares happens. Next, check if they're both squares. Do you want to be fancy?
No.
Here's the fancy people. If you want the fancy word here, I'll put it in. You don't have to write the red if you don't want to. They're both perfect squares. And then I spelled perfect wrong. That's funny, spelling perfect wrong.
Apparently it's not perfect.
That's right. It's not perfect. Perfect squares. And by perfect squares, I mean some nice number. Like 7 or 2, 4. Yeah. 3. Check if it's subtract between. I think I'm over-explaining the steps. Yeah, over-explaining. So if you're having trouble with this, you've got the beautiful steps, but it's not as complicated as it looks. Find what was squared. In each term. Then, I don't like how neat that was. I'm not going to change it. So then you're going to have a bracket and another bracket. Second, second. I don't want to put a word there. But one bracket's going to have plus. That's what you said. You said one bracket's going to have plus, one bracket's going to have minus. That's what we're going to get to here. That is too much explanation. I'm telling you, that is more explanation than we actually need. These are way easier. No, not way easier. I don't say they're easy. These are way simpler than that to actually do. But there they are. There's the steps if you need them. You need to go back and go, how does it go again? This is the steps to do it. As soon as I do one, I'm going to be watching for those. Actually, there's two different people who do it. They start flipping to the homework, and they start doing it. As I'm doing the examples, they're like, I get that example. And they flip over and do homework when they get bored. What time do you have to leave?
2:15.
I'll do one.
It's actually 2:13.
Let me do one. Yeah, we got 2 minutes. I'll go back if you need to copy it. Here it is. Is it two terms?
No.
X squared minus 25? Yeah, that's two terms. X squared and negative 25. Yes, or subtract 25. Is it subtract between them? Yeah. This is the difference of squares. Okay, what was squared to give x squared? X got squared to give x squared. What got squared to give 25? 5.
Wait, 5 is negative.
X plus 5?
Negative 5.
x minus 5. Do you see how I said it's actually simpler than the way I explained it? And if you're confused, I'm about to do 6 in a row. So if anything in that was scary, I'll slow it down and speed it up. At the same time, I'll do both. I'll slow it down so you know what's going on, but also speed it up.
Is the y-intercept 5 and negative 5?
No, 0.
Oh,
Y-intercept 0.
let me do one more of these, and then we'll talk about x and y-intercepts. Oh, no, you got to go. Okay, for y-intercept, I set x to 0, so it's negative 25. For x-intercepts, they're negative 5 and 5, because I'm saying the y to 0. Those are the zeros we've been working on all chapter. The y-intercept, though, is just this last number, this negative 25. Because if I make x equal 0, I get y-intercept negative 25. So I'm trying to add a little bit of tomorrow's lesson in there as well.
Oh, yeah. I gotta go now.
Good. Go. Fine, just go then. If you're going to go, go. Get your just stuff and may as well just go.
30, negative 32.
Hold on. This time a little slower, just in case I lost you there because I was rushing for him. Yeah? Because I'm not Russian. I'm more English than Russian. Very slowly. Is it 2 terms? Yes. X squared minus 64. There's no x term. Yeah? Is it subtract between them? Yes. Is each of these something squared? What do you square to get x squared?
8 and negative 8.
Hold on, no, just the x squared. What squares to give x squared? X. X squares to give x squared. It's almost too easy. Even as I say it, I'm messing you up. X squared is going to be x. X and x, right? Now 64. Is that something squared?
8.
He says 8. Well, how are we going to know? You could do this. If you're good with your multiplication, you go 5 times 5? No, that's 25. 6 times 6? 36. 7 times 7? 49. 8 times 8? 64. So I was like, I don't know my squares like that. But what could your calculator do to find out what was squared? Like, it'd be nice if your button, if there's a button on your calculator that undid squares. The He says it's the Square root. It says find what was squared. So if you need your calculator, hit square root 64, and then you get the number 8. So your calculator is a huge weapon here. You're like, I don't know these squares in my head. No, I'm not asking you to. The other way to do it is just square root what was there. If you get that, here's the 2 brackets. X plus 8, x minus 8. Okay, who's good enough at this to tell me then what the x-intercepts are? 8 comma negative 8? This was that opposite thing we talked about. If the y is 0, we just need the x values to go in there. Now the y-intercept is easier and harder at the same time. If I want the y-intercept, I make the x 0. Watch, here's me making x 0.
Negative 64.
Negative 64. Because if the x is 0, then that part of the equation is gone. Not the biggest point of the lesson, the x and y-intercept. I mean, it's just something I'm adding on to in there. But okay, here, then these numbers come up, and it scares you a little bit. Let's go through the checklist. Is it 2 terms?
Yeah.
It's 2 terms. 25x squared is the first term. Subtract 36, second term. Actually, the 2 terms are actually 25x squared and 36, and they've got to subtract between them. Next. Is it subtract? I already answered that. Yes, it's subtract between them. So, is there something that squares to give 36? 6, how did you do it? You just knew it. Well, what would you do in your calculator if you didn't know it? You could just square root it and see what it is. They repeat so often in the homework, you might start to know your squares a little bit. You might start to go, oh, I get those. But this one's not quite so easy. Is there something that squares to give 25x squared? That is, what do you multiply by itself and end up with 25x squared? Yeah, so now I'm giving you another way to look at it and go, don't think about squares. What do I multiply by itself to end up with 25x squared? Oh, that's 5x. 5x multiplies by 5x to give 25x squared. So now I have my 2 brackets. All right. This one's a little harder for the x and y intercepts, I must say. Let's do the y-intercept first. If x is 0, that whole thing's going to be 0. What's the y-intercept? That's all 0. Right there. Yeah, y-intercept's just negative 36. If I make y to 0, I've got to do the opposite of those.
Positive 6, negative 6.
No. So listen carefully. But Tana was raised her hand. She was smiling. I don't know if that means you got. What's that? Oh, you have to go now. I thought you were smiling that you knew what to happen here. What is it? You could FOIL it out. Yes. So this is a little review of our previous lesson. I'm going to write it way down here. Do you have room at the bottom?
No.
There's the work you had to do to get that 0. It's a little more difficult. That first one's negative 6/5. Now that you see that, maybe you can see that the other one's 6/5. Those are difficult.
Whoa.
I almost kicked the door shut. All right, that's a tough one. That's a tough one. Oh, I pressed the wrong button. Silly Mr. Todd. All right. Part D. Do I just do D, E, F, and then I'm done? And then you're going to try some homework, which is like identical to what I'm just doing here. Most of it. Okay. If you've drifted off to sleep or if you pulled your phone out, you might want to bring it back for a second. Get ready. Is it 2 terms? Yes. Is it subtract? Yes. Are these things something squared? Is there something you can square to give 2? What do you multiply by itself to give 2?
2.
2 times 2 is 4.
1.
1 times 1 is 1.
1.5.
1.5 times 1.5 is 2.25.
2 times 1.
It's got to be multiplied by itself. 0 times 0, 0.
1.8.
Did Mr. Todd mess this question up? 2 times 2 is 4. Okay, let's check the other one. 72. 2 times 0 is 0. But it's got to be by itself, too. Nothing multiplies by itself to give 2. Well, that's not true. There is something out there that does multiply by itself to give 2, but there's no nice number that does it.
Wait.
Is there another type of factoring I should be doing? What was it? The other one was trinomial factoring. It's not trinomial. This isn't a trinomial. What other type of factoring was there? It will be a parabola if I were to graph it. That is true. Oh, I need someone who did their homework.
Oh, 1.4 point, wait, 1.4.
You're right. But it's not a nice number, is it?
Why don't you put the 2
Anything past this, I'm confused.
Joseph says, why don't we put the 2 out front? Can we? Does 2 divide into both those things? Oh. I'm not trying to be add on to my life speech. I'm really not. But if you didn't do last night's homework, how could you have seen that coming? That's the problem with not doing at least some of your homework in math, is this comes up and you don't know what to do. What would be in the brackets after I take out a 2? If I take 2 out of 2x squared, what's left? X squared. What if I take 2 out of 72? Ugh. What's 72 divided by 2? 36. Does 36 square root?
Oh, yes.
So you're like, oh, okay, hang on. So here's how this works. I first check if there's a common factor. Then I check for difference of squares. Yeah. That's why this chapter is dangerous, because there's multiple steps in some of these questions. What multiplies by itself to give 36? 6. So the two brackets are plus 6 and minus 6. Then I can get the y-intercept, the x-intercepts, negative 6 and positive 6. The y-intercept, negative 72. I can read those all off. Yeah. Mr. Ty, can I just try and do it as difference of squares, and then I'll check for the common factor after? Yes, it can work, maybe. I don't know. Okay, yes, it will, mostly. Let's look at this one. Is there something that squares to give 12? No. 3 times 3 is 9. 4 times 4 is 16. So then I switch over and look for a common factor. Is there a number that divides into 12 and into 75?
Yes.
What is it? How am I supposed to find out, Mr. Tom? 2 doesn't divide into 75 because it's not even. So we try 3. Just try the next lowest one. I'm not going to make the number 11. I'm making fun of myself because there was one in the homework last night with 11. But I'm not going to make the number something really big and scary. Here it's 3. Now, does something square to give 4?
Oh, yes.
2. And does something square to give 25? Oh, yes. So now we can do it. X-intercept, that's hard. You got to take one of these and go 2x plus 5 equals 0. So x is negative 5 halves. And the other one would be positive 5 halves. So that's hard, but what about the y-intercept? That's supposed to be easy. Can you look at that and just get the y-intercept? Negative 75. It's just that number by itself. Actually, I could do a whole lesson on it tomorrow. Well, picking that off, but you basically just got to pick it off the end there. Okay, last one.
6 times 6.
He says 6 times 6. And is there something that multiplies by itself to give 100?
Yes.
10. So you could, so you go 6x plus 10, 6x minus 10. That's totally allowed. Somebody else says, wait a minute. Couldn't we common factor a 4? Could I have done it that way? And the answer is yes. And they would have got this. And my question is, which one do you like better? Or do you like one better? Mathematicians like this one better because it's got smaller numbers in it. But I'll be so happy to see the first one that I'm willing to take it. Some teachers might not. Some teachers will be like, no, no. I need to see that common factor first. Well, I don't know. It might not be time to get too excited about that. But now we're ready to get these other information. How about the y-intercept?
Negative 100.
Negative 100. X-intercepts. Yeah, so now maybe at the start of the lesson you're like, oh, negative 5. No, no, negative 5 divided by that 3 when there's a number out there, okay? Might you have to do the extra work I showed at the bottom? Yeah, maybe, as you get better at them. Any questions there? Is that the end of the first page? All right.